Okay, hi, my name is Henrik Warne, and I will talk about learning from your bugs. So for the past 15 years, I've been taking notes on the trickiest and hardest bugs that I've come across. And I think this has helped me become a better developer. So in the talk today, it'll be two parts. The first part, I will show what kind of things I write down. I'll talk a bit about what kind of bugs I take notes on, because it's not every bug that I find. And I'll give some examples so you can see what those bugs are that I think are interesting. And then, so over these 15 years, it's more than 200 bugs that I've written up. And so I've gone through all these bugs, and I've looked for patterns on what I thought were lessons learned when I fixed them. And so I've listed these lessons in three categories: in coding, testing, and debugging. So the second part, I'll go through those lessons that I've learned from this. Okay? So a little bit about myself. I'm a software developer at TriOptima here in Stockholm. Previously, I've worked at Simsoft, Tilgin, and Ericsson. You probably know of Ericsson, but probably not the other two. That's been telecom. At TriOptima, it's financial risk management. I've been programming for more than 25 years. I still code every day. I love it. Currently, I'm working in Python. Previously, Java, C++, Plex, which is a proprietary Ericsson language. On Twitter, I'm Henrik Warne. So, what bugs are interesting? Well, these are bugs that almost all of them I've found in production. So usually I've been the one that made the mistake that caused the bug too. In most cases, it's me. So the bug got through me coding. I didn't think about the case. It got through testing. It got into production, and then we had to troubleshoot to find it. So that in itself, I think, is interesting. You know, how could I miss this? It kind of bugs me a bit that it got through. And the other criteria, I think, it's if it's something that I learned something from. I learned something about like the language I'm using, or the domain, or the application. So things that make me go, aha, so that's how it works. So those are the kinds of bugs. It's not like just your average normal bug. You forgot to do an if statement, and then in the tests it fails. It's not those kinds of bugs. And so I've been doing this for 15 years. That's a long time. Why have I kept doing this? It's because it helps me to learn. I find that I learn much, much better if I try to write down a little summary of the bug, rather than just, well, typically when you're debugging something, that's not what you're supposed to do, because you don't know when the bugs come. So you have to stop things and you start debugging. And usually when you find it, you kind of breathe a sigh of relief and say, oh, okay, let's get going what we're supposed to do. So you try and put a fix out and keep going. But I try to take the little extra time of writing it down so I remember it better and learn from it. And the bonus point from that is that I can review those notes later, which I did when I went through all of them. And it's nothing fancy at all. It's just a plain text file. I call it bugs.txt. Where I enter the information for each bug. So this is what I have at the top of the file. So when I find a new bug that I want to write about, I just copy what's between the template begin and template end, paste that in at the top of the file, and then I start filling out the fields. And I think most of the headings here are self-explanatory. You'll see an example later too. But I mean, date, obvious. But symptom, how was it noticed? the cause, then I write down a little description, or maybe I have the code that caused the problem. How found, there I list how I went about to debug it. And sometimes I did the wrong thing in the beginning, and I kind of note down things that helped me find the bug. The fix can be like just a one line or the code that fixed it. It depends which files it happened in. I thought it would be useful to see. I haven't really had so much use for that. Was it caused by me or not? Most bugs that I'm recording are caused by me, but not all of them. Time taken to resolve the bug. Here I just take the time from when we notice there is a bug till I found what the problem is. I don't include the time to do like the proper fix and deploy it and stuff. It's just the time it takes me to find it. And lessons, that's the most important part. I try to write 1 or 2 sentences. What's the most noteworthy from this bug? What should I learn from this? So I'll give an example here. When I worked at Simsoft, we did SMS delivery systems. And for long SMSs, they can come in parts. And the parts can come in out of sequence, and they can come in on different nodes and stuff. And at first, we wrote all the parts down to the database and then read them up and delivered the whole complete message. But we wanted to collect the pieces in memory. And to do that, we had to make sure we got all the pieces to the correct node. And so say we have 3 nodes, and they come in on different nodes. We have to redirect them to the correct node. So we had an array that stored the addresses to the nodes. And then we used the hash code of the phone number, and then we took that modulo the number of nodes, so you would get a number 0, 1, or 2, say, if there are 3 nodes. 0, 1, or 2 to say which node to go to, so you look it up in the array, where should we send this part. That, we implemented that, I wrote tests, deployed it, it worked. But then we got an array index out of bounds. And I thought that was strange, but I got the phone number, so I just plugged it into the unit test that I had, and I got like -1 as the index. And the problem was that the hash code returns an int, and an int can be negative and positive. And I just assumed that it would just be a positive number, and it was in most cases. But I got a negative number on the phone number that caused the problem. So this is what I wrote up for this one then. It happened in 2013. I wrote the Jira ticket number because I had one there. The cause, hash code can have negative values as well, which I didn't think about before I encountered this. That's why I thought it was an interesting bug to record. A little bit about how we found it. The fix, I just did math abs after I did the modular part. So that fixes it, no big problem. Fixed in a file there. We discussed this at work too, and another interesting thing, because we just talked about binary numbers, and there's like one more negative number than positive numbers in binary. So the most negative number you can't represent as the positive. So I thought, what would happen if you take the math abs of the most negative number, the min value, and it turns out that it returns the same value. So you still get a negative value, which I kind of learned from this too, even though that didn't happen. Was this caused by me? Yes. It took 30 minutes because we had really good stack trace and we got the phone number as well. So I could just plug it into my test that I already had, so it's quick to find once it happened. Lesson is to consider negative numbers for hash codes. Here's another example. It's an older one from when I worked at Tilgin. In telecom, you often use these tag length value messages. So you have like a tag that say what information piece is it, like a phone number or a service that's activated. And then you have a length and then the actual value. And those can nest as well, as you see in this picture. So when you decode that, you can skip pieces that you're not interested in. So that's a good property. So you can skip if you don't recognize a certain tag, you can just skip over it and take out the pieces you want. So we had an implementation that worked, but for a certain case, we got an infinite loop. And it turned out that we got a message, or we had data that had a length value of 0. And our code would use the length field to see how far to skip. And so skip 0 steps ahead, so it landed on the same. So we kept looping there. So that was an interesting bug, I thought, too. And our code was careful to check that you don't jump too far out of the buffer of the message. But we had no checks that checked that we actually made progress when we parsed. This is what I wrote about that one. 2004, infinite loop, Q931 is the protocol. I saw, when I prepared these slides, I saw a funny thing. Who here has used Wireshark? Okay, who here has used Wireshark before it was called Wireshark? Does anybody know what it was called? Yeah, ethereal, because that's what I wrote in this description. A message taken from an ethereal trace from Nortel. Nortel don't exist anymore either. I looked that up, but they went bankrupt in 2009 or something. Anyway, here's a bit of a longer explanation of how we found this problem, because we cut something out of the trace and pasted it in, and it happened to have zeros that caused this bug. So it wasn't an actual message, but nevertheless, you want to be sure in your decoding that you don't get stuck in an infinite loop. We just set it to 1 if the length was 0. That was our fix, and it worked in that case. It took an hour to find. Consider 0 length as well. Okay, so when I do this, sometimes, if I don't write it down immediately or within a day, I'd never get around to it. So I think to do this, it's good to write it down as soon as you can after you've found the bug, because there are other things you want to do, and you just kind of forget about it, and also that you don't remember all the details. So it's good to take the time. It doesn't take very long to write it down. And also, I think it's a real difference between writing it down and just thinking about it. Because when you write it down, you kind of expose how did I really find it, or does this actually work the way I'm thinking it works? So for me anyway, writing it down makes it stick much better. And plus then I get I can review it later. And of course, I just do this because I think it's useful, so it's up to me to decide which bugs are interesting. But in these 2 previous ones that I showed you, it's things that kind of made me go, I didn't think about that. And those are like good signs that I should maybe write this down so I really remember this. So the number of bugs per year, I just made this graph to see. I started doing this in 2002, and the peak was 2003, and then it's gone down, and now I'm kind of at 1 bug every other month. So maybe this shows that I've gotten better. That's one interpretation. I also note that I was using C++ the first 5 years of this graph. And then it was Java, and then it's Python. But I don't know if that's the reason. But you can interpret it in different ways. But I just thought it was interesting to look at the stats this way. This is the number of hours taken to to resolve it. And that's just finding it. So, and this is in hours. So, I mean, you can see up from 1 up till 8 hours, I'll write like the hours, then I'll write 1.5 days, or 2 days, 2.5 days, 3 days. And then it's more than 3 days. It's 5 bugs that took more than 3 days to find. The longest one took like 7 days of just solid debugging. But so most of them are pretty quick to find, actually, once you're aware of them, which is kind of interesting too. Okay, so so this is mostly from these lessons learned from that you saw before, the lessons that I've extracted here. And so in the first category is coding. And the first one there is event order. So many bugs were from events happening in unexpected sequences. So maybe if they arrive in a different order than usual, or if you never receive it, like you need a timer to time out if you don't get the message. What happens if you get the same message again, even though you shouldn't? What does the code do? And I also seen that most of this doesn't happen, but bugs in neighboring systems can cause these things to happen. So you get the same message repeated or things like that. So it's really good to ask what happens with the events if the order is different, and how can we handle it? Too early. That's in a way a special case of the event order. For example, when a server was rebooting and we allowed traffic in before we've read all the configuration. So as we were building the configuration, we started processing traffic, and we got really weird errors and lots of errors within like a few hundred milliseconds. So that's one example. The other was a really tricky bug we had where a device was in a list, and it was, if it became down, it should be taken out of the list. And every once in a while, we'd find devices that were in state down in the list, and we could not understand how this could happen. We had lots of checks around, when it goes to down, take it out of the list. But in the end, it turned out that there was a race condition when the device was created. So exactly when it was created, it was put in state down and put into the list. And we couldn't even imagine that it was down before it got put into the list, but that's why it was down. And that took us a long time. So that's a useful thing to think about too. Are things happening earlier than we expect? Silent failures. I think everybody knows this is bad. You should throw an exception rather than silently fail and continue. But there are some cases where you forget to check this. For example, like system calls that almost always work, like getting memory, or if the disk is full. It's often that you don't check those result codes, and then you could keep going even though it failed. But in general, throw an explicit error and then try to handle that rather than continuing. If statements. There have been a number of bugs where it's just if is almost as simple as it gets. But nested ifs, I've seen cases where you don't end up in the right part you think you will, because there is an if and then another if, and the else part is not the outer else, it's the inner else. So stuff like that. Or even worse, when you have several expressions, or long, you could have like if something, 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 else if something, something, something slightly different, else something, something different again. And those get really hard to reason about. So I think these days I try to just rewrite this so you can unit test it well and have it as a separate part instead of building onto these long chains of if, else, if, that can get really hard to understand. Another thing, often when you have an if, it's at least good to ask, should there also be an else statement here? Or an else branch, rather. So what should I do if it's not the true case? And think about what that needs to be. And a related thing is one bug I had where I set a flag, but I wasn't thinking about when it should be reset. And so the program kept going, and then we came back to that point, but the flag was already set because I hadn't thought about when do I need to clear this flag, and that caused the bug because the flag was set for the wrong condition. Logging. Not too much, not too little. I think in general, I've seen both cases, like sometimes people log way too much so that it's just can overwhelm it, but more often I think it's not logging enough, especially for the failure cases. I think you want to have, you have like the happy path and everything works, you get a result back, but all the branches off there where something goes wrong, I think it's important to have logging that shows you, it failed here, and this is why, so that you can see when things go wrong more easily. And sometimes when I discuss this, people say, well, you just look at the stack trace when things went wrong. But I mean, you can go wrong, but it's just no exceptions are thrown, it's just the wrong result. And when I worked at Simsoft, we had logic that was routing SMSs the cheapest path, and it got a lot of complicated configuration to decide which path should we take, which is cheapest in this case. And so it was very useful to have logging that kind of had a little short description which path we took, so that when things don't work, we can look in the logs and figure out why did we get the wrong route. And finally, changing assumptions. So as things change, it's easy to change all the explicit dependencies. You know, you add an argument to a function, and then it's easy to find all those places that calls it, and you know you have to change. But there are several, or often, implicit assumptions. You assume things about the code, but it's not obvious from the code itself that you've assumed that. So for example, if you start out and you have like one customer event per day, so that means that for any given day, there will only be as many events as there are customers. So that can be an implicit assumption about code somewhere. And then when you change this, so there are more customer events per day than more than one per customer, then this is not true anymore, but it can be hard to find those places in the code where that happens. And this is something I don't really have a solution for how to detect this, because it's really hard to know all these implicit assumptions and who should find out. I mean, the only way I have thought about is like that can help you is if you know the system well, you know how things work. But that's not the case for big systems, so I really don't have a good solution for this. Right. So for testing. The first one, this is also well known, 0 and null. So for example, for a string, you want to test both when it's null and when it's like an empty string, just no characters. But this can show up in other cases as well. We had a case where we had a TCP connection, and when we closed it, we did some statistics on it. And when no bytes had been sent, these statistics failed them through an exception, because they always assume there was at least one byte sent, but in that case, there weren't any. So that's another example of 0 that is useful to test for. And these tests, 0 and null, I think is useful both in your automatic tests or checks, and when you play around with the system and try and setting things to null or 0 and see what happens. Add and remove. So this has bitten me many times. Often, like you write a feature, you add something new to the system. So when you test it, you try and add this new thing, like new configuration, a new way of doing things. But you also need to test to remove this new thing, or take it away again and see that it still works, to add it and remove it. And frequently, I forgot to test the remove part. So it worked to add it, but when you took it away, it failed. Error handling. It's usually hard to test the error handling. So one thing that I'm usually doing now is to separate the triggering of the error from the handling of it, because then you can easily test the handling of it without having to have the error. And another thing that I sometimes do, just to see that everything works kind of, is I will flip some condition in the code, so that I cause the error even though nothing has happened, just to see that everything works. And for example, for a database, like some people, they will mock it out and test it. But then you're assuming things about how you will get the errors from the database. So sometimes what I've done too is I've like misspelled the column name just to get an error thrown back from the database and see that it handles it properly the way I think it should. Random input or fuzzing. I think it's not easy to use in all cases, but when it is applicable, I think it's really, really useful. When I worked at Tilgin, we had this H323 protocol for VoIP calls, and it had a binary encoding. And so we just sent random bytes into that, and that found a lot of problems. Really amazing how many problems we had in our code that we hadn't noticed. One thing was, like, we got like huge loops that would be for like 2 billion turns, so we would time out long before we could finish looping. So that was really, really good. And we also at Tilgin had, for the VoIP calls, we had test phones that we generated random calls between the many phones to try and flush out problems with signaling and stuff. And so we generate lots of scripts where you had like 60 phones and they call each other. You know, you do off hook, you dial a number, you wait a random time, you answer the call, you wait a random time, you hang up both at the same time to see if they cross in the buffer and stuff like that. And those scripts found a lot of problems as well. And that's actually more so than C++, the culprit for those lots of bugs in the beginning. Lots of these problems were handling the signaling that we hadn't thought about, but we found through these random scripts. And one good thing to do if you use like random scripts like that, it's to keep track of the seed that was used so that you can regenerate exactly the same random sequence. Because sometimes when you want to debug something, you want to rerun exactly the same script and see, print out more information, for example. Another thing that's easy to miss is to check what shouldn't happen, because we're so focused on checking. This is kind of like the add and remove. Yeah, we're focused on what should happen, and we see, yeah, it did happen. But maybe it's wrong if that also happened without this starting action. So you need to be aware of, to keep an eye on things that shouldn't happen. And I think this I usually find more when I play around with the system than when I write tests. Because then, I use the system in as real a setting as I can. I look at logs and I see, does everything look right? And then often you'll say, oh, but this happened, but that shouldn't happen now. But it's good to be aware of that. You should look for these things. Writing your own tools. For me, that's been very, very useful as well. When I was testing the zip protocol for VoIP calls, then I wrote like 10 lines of Ruby to reply to. You send out a message and then you send a reply. But in the message you send out, you have like some random number that has to come back. So the script is there just to make sure you get the right things back. But this script I gradually expanded so I could test these weird things where you get invalid responses and stuff. It's very easy to do with the script. You just set it to send whatever you want it sent, so you can test that the code behaves right. So having this tool and building it out gradually was really useful. And I used it debugging when debugging a lot as well. Same at work now. We have microservices where we can we have API calls to all the services. So I just have a little tool that I can do all these API calls. Even it doesn't come from the GUI. I can call each service directly. And that one I also been building out, and it's become a very useful tool for debugging and testing. And in both these cases, I just started really small, just do one thing. And when I found it useful, I kind of added to it and kept adding it. And it's become a really good tool to use. So you won't find all the bugs by testing, though. And we had one bug at Simsoft where we had like a fixed part, the 444, and then a dynamic part, like 357 here. And then we used the dynamic part, made it into an integer, and used that as a key in a hash map. But the bug was that we cut off too much. We should have cut off 444, but we were actually cutting off 4443. So it was just 57 left in this example. And for that case, from 000 to 099, it worked fine. But then when you get up to 100 and all the way up to 999, it didn't work. So it worked the first 100 times, and then the next 900 times it didn't work. So I thought that was kind of an interesting bug as well. We tested it, it worked, but not if you ran it long enough. Okay, so for debugging, the number one lesson I've written down is to discuss with a colleague. It's for all the trickiest bugs, it's been the number one lesson. That's what made me find the bug, or us find the bug, because we were discussing it. And the good thing is, if you discuss it with it's like the rubber ducking thing too. Sometimes you don't even have to talk to a person. You can just say it out aloud what the problem is, and then you'll start thinking and realize what the problem is. But for colleagues, sometimes you're lucky enough that they know the code as well, so they can have really good suggestions. What could it be? But even if that's not the case, it's good. You can just go and talk to them, and they usually be able to say, well, could it be this, could it be that? They're good for coming up with suggestions, even if they don't know exactly how the code works. And like I said, so this has been the top lesson to talk to colleagues when I have a tricky bug. Also, when debugging, pay close attention. Many of the ones that took a long time to find, I had made false assumptions. I thought that I was coming to a certain point in the code, but I didn't get there. Or I'd gone to that point and passed and were somewhere else. And I stubbornly thought that something in this method went wrong. Or I assumed there was a certain exception thrown, but it wasn't. It was another exception. Maybe a null pointer exception that was unexpected, and I just assumed it was one that I thought it was. At one point, I thought I had made a new release and loaded it, but it was the same older release that was running. So it's good to be able to see which version is running, because that really confused me. Also, this I've done too. You have a printout and you say A equals, but the value you print out is the value of B. And then when you look at the printouts, A is this, and you can, oh yeah, A is this, but it's not. So all these little details has made it take a long time to find some of the bugs. The most recent change, it's surprising how often this is the case, that's what broke it, and there are cases where I still didn't get it. For example, I only updated some logging code, and then we started getting exceptions. But it turned out that in the logging, I was trying to read out a number from a phone number, and we didn't always have that phone number, so I got a null pointer exception trying to log this non-existent phone number. So in that case, even though it was only logging code that changed, it was still the most recent change that was at fault. Another tricky one I had was I just did a merge, but it was a really old commit that I got in through the merge, and that was the problem in that old commit. So that was a tricky one too, but it was also the most recent change that made it fail. But I think like the continuous delivery really helps here, because then you just deploy smaller changes, so there isn't that much in the most recent change, so it's much easier to find. So I found that a big help when we've started to use that. Believe the user. I think we as developers have a tendency to say, well, that can't happen, impossible. They must have done something wrong, configured it wrong, whatever. But I've learned not to assume that, because so many times they've been right. You know? I always, you know, you always have to make sure, did you do this? Did you configure it correctly and stuff? But sometimes they use it in ways we hadn't even thought about. Oh, you could do it this way. Oh, yeah. Or sometimes it's just because of their configuration and their way of using it, they get bugs that we've never seen. So these days, I always at least think it's a possibility that they're right. They're not always right, but you shouldn't dismiss it out of hand, because so many times I've been wrong about that. So I've learned not to do that. And the final one, which is a simple one that maybe everybody already does, but it's good to be reminded of it, because it saved me several times. You want to recreate the problem, and sometimes I can't. I read the code and I say, oh, this must be wrong. But when I try to recreate it, I can't, because it turned out that there was no way you could get there, or I read the code wrong. So first step is to recreate it so you actually see it happening. Then you want to have your fix. You want to just add the fix, rerun the test, and see that it's gone. That's the way to do it. And like I said, this has saved me many times. I think I always try to do that when I fix a bug. Right, so that's the presentation. I think this is something that's very easy to do. It doesn't take a lot of time, only requires a text file. And I think it really makes you reflect on what you could learn from this. And especially for these things that you find in production now. How did it get through all the way out? And writing it down is so much better than just trying to think about it, in my experience anyway. And the key thing to write down is, what lessons did I learn from this? And then when you have it written down, you can also review it if you want to, which I've done a few times, not so often. But just the fact that I'm writing it down has been really helpful, I think. So that's it. Any questions? Okay, I'll be around, so come and talk to me after if you have any questions you don't want to ask here now. It's okay. Thank you.